Hi there. Welcome back to this channel. All right, let's quickly discuss mensuration. We are going to be discussing the following terms that are associated with circles, arcs, sectors, and segments. All right, so we have this circle. Now, for example, if now this is the center of the circle. I mean, remember that revolution thing that we talked about. So that the circle is going to a particular radius will be used to, draw this circle. That material is going to revolve around this way at a particular radius. So that radius is going to go around the entire length of this circle. Is that okay? So now, this center is, this point here is the middle or center of the circle. And when the angle at that point is also 360 degrees that emanated into this cyclic 360 degrees also. So if I draw a point here, for example, from here, I draw a point to meet at the circumference here. This is going to be called the radius. And if I draw any point from that center there, it's always going to be called a radius. Why? Because the length is always the same as far as, because it is equidistant from the circumference. In fact, it's not a circle if it's not equidistant from a fixed point. So because that length is equidistant, every point on this circumference is equidistant from it means it have equal distance from the circle. And that's why it's called a radius. All right, now, this is called a radius. Now, what does a radius give rise to? Notice that these 2 points, from here to here, if I walk from here to here like this, from this place to this place, on this circle, I have walked a particular, it's called an arc. This line here, this length here is called an arc. An arc is any particular distance on the circumference. The entire length of the circle is called a circumference or a perimeter. Is that okay? Now it's called circumference because it is round. The word circum means round. It refers to something that is round, that is going in a cyclic, right, in a cyclic shape. So this guy is called an arc. And because it is smaller than here, obviously smaller than this arc here, it will be called the minor arc. And the bigger arc is going to be called what? The major arc or the great arc. So this is the small arc and the great arc. Is that okay? Now, what an arc does is this. If the arc could be traced back to the center to form two radii, is going to give rise to what is called a sector. So a sector is the pie shape that you form. So when you form a pie shape, this shape, obviously from what we have here, we're going to have this shape. So this is called a sector of the circle. This is called a sector. So this will be called what? The minor sector as well. Why this will be called what? The major sector. Is that okay? Now, having had this, there is also something else about the circle. Now, we also have, from this point, I could decide to walk from here to here. And then I will now join those 2 points with a horizontal line, for example, a horizontal straight line, and that line will be called a chord. It's called what? A chord. And you notice that as I proceed towards the center, the length of the chord increases until I get to the center where I have my longest chord, which is called what? The diameter. So the diameter is the longest chord. And notice it is made up of 2 radii too. Is that okay? So 2 radii will give us what? A diameter. Now, and the diameter is going to be the longest chord, of course, because if you pass the center again forward, you are going to have smaller chords. Is that okay? So, and what does a chord do? A chord actually splits a circle into 2 parts also, which are what? Segments. Which are what? Segments. So a segment is essentially different from a sector because a segment is not made from 2 radii, while a sector is made of 2 radii. Is that okay? So that is why we don't necessarily call, diameter has its own separate name. Is that okay? Because it is made up of 2 radii and yet is a chord. Is that okay? Now, a chord splits into what we call segment. The smallest segment being what? A minor segment, and this will be what? The major segment. And notice the great arc is also for the major segment, and the smaller arc is for the what? Minor segment. Good. Having understood that, what do we have of these guys? Now we can begin to calculate some characteristics, such as the area. For example, we could calculate the area of this sector. Notice this is only a small part of that circle. This is only a small part of the circle. Now we could calculate the area of the sector. Now, how do you calculate the area of the sector? It's very simple. Now listen. You remember that this chord, this arc, actually, this arc moves, this arc is the same, it subtends an angle in the middle. It subtends an angle in the middle. Now, when I'm going to be teaching you circle theorem, I'm going to be teaching you more about this in that video. But also, you can watch the video that I made on simple harmonic motion to understand what happens here in a way, because I explained a little bit of circles there. Now, this circle subtends an angle in the center, and this bigger arc also subtends an angle here. Is that okay? So to show that the entire distance is still 360 degrees. Now, this angle that is subtending here is equal in magnitude to the angle here. Is that okay? Now, take for example, I have a circle. We are going to area of circle. Now watch. If I have a circle, an orange like this, and I split into these three parts like this, that is 6 parts altogether. And I gave you this part. How many have I given you? I've given you 1 out of what? 6. Because I have 1, 2, 3, 1, 2, 3. I have 6 parts there, and I'm giving you only 1 part, isn't it? Now, the same way, this guy here, this entire thing here, this area here, that's what we're looking for. Is that okay? So this area here is only in angle, is only a part of a fraction now of the 360 degree revolution of the circle. So it means that this guy here is only theta out of the entire 360. It's only an angle out of the entire 360 degrees. Is that okay? Now, because the entire area here, the entire area of this circle, that is the entire area that is occupying, is actually pi r squared. So since it is pi r squared, then it's going to be that we took a fraction of pi r squared. Do you understand? We took an angular fraction of what? Pi r squared. So that's why the formula for area of circle is what? Theta over 360 times what? Pi r squared. Do we understand? Now it's as simple as that. Now, what if I were asked to calculate the length of this arc? The length. How long is this arc? Very simple also. The length of arc. Remember, this is our radii. And remember, they are going to be equal. Is that okay? They are going to be equal in magnitude. Length of arc now, of an arc, is going to be how? It's going to be what? Remember that this entire length, which is the perimeter of the circle, which we call the what? The circumference of the circle, is equal to what? 2 pi r, isn't it? Now, because it's equal to 2 pi r, what is now the length of this arc? Remember also that this length is only an angle out of what? 360. So it's a fraction of what? Of the entire length. So it's as if you don't need to cram anything. You don't need to cram anything. Just understand that once you understand the components you are looking for, you can actually work out your what? Your formula by yourself. Since this is an arc, so the length of this arc is going to be a fraction of the entire length of the circle. Just like we have the area, which is what? A fraction of the entire area of the circle. You understand that? Now let's go to the next thing we can also calculate of this. Now, for example, remember, I'm going to prove a formula for us here. Do you remember this formula that says that the area of a triangle? Okay, for example, I asked one of my students to calculate the I think it was area. Yes. If you ask to calculate the perimeter of a segment, yes. So, for example, now this is a segment here. I asked him to calculate the area of the segment. Okay, but before we do that, now let's calculate the area, the perimeter, of course, the perimeter of the entire shape here. Now remember that we said this is a sector, right? Now, if we want to calculate the perimeter, for example, let's go by first calculating the area of this segment. since we are still dealing with area. So we've done this sector now. If you want to calculate the area of segments, it's simple also. Area of segments. Area of segment. You remember that this is a segment and it's only a part of what a bigger circle. So the other side of the circle is going to be the other segment. Is that okay? All right. Now, how do we calculate the area of this segment? Now, it's very simple. Now, the area of this circle, if you recollect, if you can see, I mean, as you can see rather, is a part of the area of what? Is a part of the sector. So since the segment is a part of the sector, what do? We basically do what? Do what here? So for example, we name this AOB, for example. If we name this AOB, and so what we'll just do is what? Subtract. So the area of the segment is going to be what? The area of the sector AOB minus the area of this shape alone. What shape is that? The triangle. Recalling that there is a theta, an angle theta there. So we say area of sector minus area of this entire sector minus area of triangle AOB. Do we understand? So now what is the area of sector? The formula is what? We said it was what? Theta over 360 times pi r squared. Now, minus what is the formula for the area of triangle? The formula is what? Half r squared sine theta. Now listen. You don't have to cram anything. Let me prove what this formula is. I've proven this, right? With that. Where did this formula emanate from? It's very simple. Look at this triangle, for example. Now look at this triangle. This triangle. Now for this guy, no, let's start with a rectangle, a square. What's formula for the area of a square? Because they have equal length, it says what? Length times length. Why? Because this length appeared in this length number of times. Is that okay? The same way for a rectangle, length and breadth. Length appears in breadth number of times. Is that okay? So that is why this guy is what is L squared. But actually, there's something hidden here that you don't know. Now, that L squared is not just L squared. We are not multiplying that. We are actually multiplying with respect to a particular angle. And that is why we call them rectangles. They are erect. They are standing erect. And because they are standing erect, it means that the angle that they are subtending here, the angles here are what? 90 degrees. So what you have here actually is that is length times length sine theta. Sine of a particular angle. Is that okay? So this is length times length sine, because the angle is 90 degrees. So sine 90. So we have length times length times what is sine 90? 1. So because it is 1, so we just barely simply say what? It is L squared. So for this case here, we are going to adopt the same principle by saying that it's going to what? R. Now, where does this half come from? Is this. If I decide to split this thing in half, I have what? A triangle. I have a triangle. Look at it. I have my triangle. So because I have my triangle, I can easily say that it is half of this length times length sine theta. And that is what we have there. Because if I decide to bring this up here, I form a kite. And what is the area of kite? Length times length also. Is that okay? Now only that this has an angle here, and the angle is not now 90 degrees because it's not a right angle. To be honest, so because it is not a right angle, the angle subtended here is not 90 degrees. So that's why you are going to have a different answer here. Yeah, I mean, that this formula looks like it's different. It's not so different. It is just half of that complete shape times, which is the length times length, sine of the angle at which those lines are meeting. Is that okay? So that is where that formula comes from. And this formula is going to be the formula for what? The area of this segment here. The area of this segment. We basically subtract this shape, this triangle, from the entire sector, and we'll get the area of the segment. Okay, so I now ask my students, how about the length of this, the perimeter? What did I ask him? I think I asked him the perimeter of, yes, the perimeter of this place, the perimeter of the segment. Now, how do you do this? It's simple, so it's very simple. Now, what does perimeter mean? You must understand, see, to get all these things, maths is very simple. Just understand the terms. If you understand the terms, I bet you are going to really understand it. You're going to easily understand them. So, for example, now, what is a perimeter? I'm asking you to find the perimeter of this segment. You know, it's a segment. The perimeter of a segment, the perimeter actually is gotten from two words. Peri. Peri means the outside edge, or boundary, or the outside edge, just the boundaries. Okay. So, for example, you remember that if you were asked to find the area, the length or whatever, what is this? To find this is a rectangle. If you have to find the perimeter of this rectangle, if I say this was my length and this is my breadth, of course. Now, this is also a length because I repeated this guy here on the 2D plane, and this guy is also the breadth, isn't it? All right. Now, what is length? I said length simply means the distance throughout the entire length. Do you understand? So if I add all these lengths together, now this is also a length. Is that okay? Because it is shorter than the other side, we call it a breadth. Do we understand? But it's a type of length also. Now, so if I add this side here, plus this side here, plus this side here, plus this other side here also, this is my perimeter. That is, I'll add all the lengths together. And that's why the formula for this guy is what? If I add L plus B plus L plus B, what do I have? 2L, that's 2L plus 2B. Is that okay? So I now have 2 into bracket what? L plus B by factorizing. And this is what? The formula for what? Perimeter of a rectangle. Do you understand? So the same way there, we are going to be adding all the lengths. Do you understand? So we have 2 lengths that I want to add. This is the shape of the segment, isn't it? So we want to add this length, comma, so it's equal to this length plus this length, isn't it? Let me draw it well. This length plus this length. Now we already know this. We already know this length because it's length of an arc, isn't it? And we said the formula for length of an arc. We said you don't have to cram it. Just remember that it is a part of a circle, isn't it? So it's going to be what? Length of arc. So it's going to be what? Theta out of 360, a fraction in angle because it's an angle. Now I said it is an angle, so it's going to be theta over 360 times what? Times what? The length of the circle, which is what? Pi r squared. To show you that 2 pi r. To show you that it is a part of is just a fraction of this entire length of the circle. So we are going to be adding this to this side. Now, how do you get this side? It is very, very simple. It is very, very simple. What do you do? Let's come and take this triangle. Now we have this triangle. We have this triangle. How do you take the length of this side alone? It's very simple. What we have is this. We have this R and this R, and we have our angle here being subtended. Now what you do is this. Divide this guy into 2. Now when you divide this guy into 2, what we have here is going to be what we have here. So it means that whatever x angle we get, x distance we get here, is going to be x distance here. So we are going to double it. Do you understand that? So recall that the reason why we are splitting into an angle is because what? We can work with the principle of what? Pythagoras, or the principle of the three functions that work with a right angle. So we can have our right angle here, and recall that there will be 2 actually. There will be 2. So we have this angle, which is this side, and we have this angle, which is this side. But we're dealing with only one. Is that okay? So we have R here and we have X here. Now this means it has become what? Because we have split it in half, it has become half of theta. Do we understand? So it has become half of theta. Now what do you get? How do you get this side? Now remember that this side is going to be what? Relative to this angle. This side is going to be the opposite. And this side, which is the longest part of the triangle, is the hypotenuse. So which function of those functions? We have SOHCAHTOA or SOHCAHTOA. Now, which function combines opposites? We have the opposite here. That's what you should ask yourself. What are the sides you have? Now, you can also, if you are giving a particular angle here, you can also by yourself find this side. For example, if you are giving 40 here, you know that this place will be 50 because it's 90. Because an angle in the triangle is 180 degrees. So you know this place is 50. So you can use relative to this angle as well. Anyhow you want it. But because we aren't giving definite angles here, that's why I'm using this. So I have this is the side I'm looking for. Is that okay? Now, if this is the side I'm looking for, relative to this angle, this will be opposite. Opposite is the side facing the angle. So because this guy is facing this side, this will be the opposite. Now, I also have my hypotenuse. My hypotenuse is given as the radius of the circle. Don't forget, it came from a circle. So my hypotenuse is given as the radius of the circle. So which function combines opposite and hypotenuse? It is sine. So what do I have there? I therefore have the sine of theta over 2 Sine of that angle, theta over 2, is equal to what? Opposite, which is this place, over what? R. Is that okay? So, and this x is what I'm looking for. So my x becomes what? Sine of theta over 2 times what? R. And that becomes my formula for x. Do we understand? So now. That's not all. That's not all. Okay. In fact, we can't even write that as a formula yet, because as it is here, it has to be R times, so x will be equal to R times sine theta over 2. Is that okay? Now recall also that we are going to double this. So because we are doubling this, x becomes, because we are doubling this, why? Because there are two sides, there are two sides. So whatever we have, we are going to double that with 2r sine theta over 2. And this is the formula that works with it. So when we now want to find the perimeter, so the perimeter will be equal to this guy. Let me clean that side so that we'll come out with the perfect formula. So we say perimeter of a segment is equal to what? Is equal to, this will be 2x. Okay, this will be 2x now. So that will be the length of arc plus the length of this guy. So the perimeter of this guy here is going to be equal to this plus this, isn't it? So, and this gave us what? 2r sine theta over 2 plus what? Theta over 360 times 2 pi r, right? And that is the formula for finding the perimeter of the segment. With this, we come to the end of the video. If you have any question about this thing, just ask. It's very simple. What you want to do is, don't cram. What you want to do is understand all the parts of a circle, and then you will know how to apply all the principles. You will know what and what to remove, what to add, to be able to get anything at all out of these guy. So, and that is, so if you have to find the perimeter of this thing too, and you're not given this side, you already know how to find this side. Is that okay? So, and that is how to go about it. If you have any question, please do well to share it in the comment section. I'll come back and answer them. And I'm sorry for the power outage. God bless you. Just share with your friends that needs it, and see you in another video.